Vocal check, 1, 2, 3, we're rolling. Okay, so I'm going to use Packet Tracer and show this implementing Etherchannel lab using the new cool feature in the new Packet Tracer 8.0 that's got some good physical stuff. So I'm going to start by going ahead and creating this physical layout and sort of duplicate the graphic, the logical graphic that's on the top of our lab. So I'm going to click on Physical, and I'll click on where it says Home City. Then I'll click on Corporate Office. Then I'll click on Main Wiring Closet. And then I'm going to put in a desk and a rack and a second rack and a desk to correspond roughly to the equivalent of what the logical layout is doing. Oh, that's cool. It's sort of like a mirror image stuff. Okay, so John, okay, just make sure my audio was still working here. Okay, so we're going to pull a PC into the topology. So I'll click on the PC group, and I'll drag a PC here, and I'll drag a PC here, and then we'll click on the network devices group and pick a switch, and I'll drag a switch up to about here, and I'll drag another switch up to about here, where it's roughly the same. Let me see if I can move it up a little bit. I have to move the little power supply up to the top. It's tricky, it doesn't want to go here. There we go. That's not a top of rack switch, that's a power connector, like a power strip. Okay, so I got the switches mostly connected to each other, and let's make this a little bigger to where we can see as many of the interfaces as possible. Okay, I can't make it any bigger because it would make the, well, I can make it a little bit bigger. Let's see, how does that look on the, if I make it too big, it drops off to the side there. Okay, so what I'll do is pull through these connections. So I'm going to click on the jagged lightning bolt connector thing, choose an Ethernet cable, hold the mouse right over the Ethernet connection on PC1, and it changes to fast Ethernet, and I drag that over to port number 6 of the first switch. And I'll do the same thing for the second PC on the right. He's supposed to go to port number 18. If you hold the mouse over here, he'll light up and tell you what port number it is. I want it to be port number 18. Now I'm going to connect the two switches together between their first port and their second port. And I'm going to use a little trick in Packet Tracer here. I'll go ahead and click on the first one, and click on port number 1, and go and click on port number 2. And I'm just going to use a crossover cable for the second one. I get lightning bolt, crossover cable. And I'll connect that to port number 2 of both switches. Yep. Well, come on now. Crossover cable. Port 2, port 2, there we go. So that way, they're both, all the switches are auto MDIX. Doesn't matter whether you use a straight through cable or a crossover cable. I'm just doing it so we can tell the Ethernet cable that goes between port 1 and 1, and then when it goes between port 2 and 2, they're slightly different colors, so it's easier to see them. Okay, now let me jump back to our logical topology for just a second. And if I drag things around here, it'll look more like what they have on the front page of the lab. So the front page of the lab looks something like this. We're going to take these two wires between the two switches, we're going to bond them together and make an ether channel. But the physical view gives you much more intuitive, hands-on type of, I get to get my grubby grimmies on the goodies type of thing. You can drag the wires around and put the devices where you want them to go. Now, in this lab, we're going to be configuring the switches to be on one VLAN, the 10-dot network. They'll be able to talk to and ping each other. The two PCs will be on the VLAN 20. They'll be 20 dot something. They'll be able to ping each other. There's no inter VLAN routing in this lab. So the switches, no switch can ping no PC can ping no switch. They'll just be able to ping each other. Okay, so let's start off. First of all, before I start doing the configuration settings for each switch, I'm going to fix this physical topology where the labels are correct. So I'll click on the PC, and we want to configure it so that it's PC-A. And I'm going to configure PCB, so it's PC-B. And then I'll configure switch 1 to where it says S1. That's the display name. We haven't done the configuration of the host name yet. And then I'll configure switch 2. It can be switch 2. Now the physical layout diagrams matches the what will be in the topology. Teeny weeny font size, that's the biggest I can blow it up. Now let's go into, we've completed part 1, step 1 in the middle of page 2. We've attached the devices and cabled them as necessary. And we're going to apply a device name to the switch. So let's go to the console for switch 1. And I'll blow it up a little bit where it's easy to see. So let's go to the privilege exec mode, and then go to the global configuration mode, and give this guy a host name of S1. That matches what it says here. No IP domain lookup, so we don't get any hangups with mistakes. Enable secret class. Then he has us go to the line VTY 0 through 15. Oops, gotta flip the page here. And make the password Cisco and give the login command to enable logins. Then the service password encryption. Did I spell that correctly? Oh, good. And then we're supposed to do, let me go out and go back into the configuration mode again. And then banner, message of the day, warning, authorized users only, whatever your lawyers tell you to say. And then we're supposed to do a copy, run, start. Save that. I'm not going to set the clock. Oops. Tried to do a copy, run, start, and I was in the global configuration mode. I didn't preset it with the word do. I'll just drop back to the privilege exec mode, and I'll do copy, run. Leave it with the tab key so you can see that it's exactly spelled that way. And let's see now, I think he has told us to do everything on switch 2 as well. So if I'm allowed to go back on both switches, configure the settings for each switch. So I will repeat this for switch 2 now. All these things we did on switch 1, we'll repeat on switch 2. So I'll go to the privilege exec mode, global configuration mode, hostname S2, and actually yeah, okay. IP, no, IP domain lookup. I'm abbreviating it there. Oops, I didn't like that. Let's go back. Configure terminal, no IP, domain lookup. And then enable secret class. So that's the password required to get from the user exec mode to the privilege exec mode. Line console 0. Password Cisco. Line VTY 0 through 15, password Cisco, login. And service, I'm going to go back to the user exec mode, privilege exec mode, and then promote myself back to the global configuration mode, because in Packet Tracer, sometimes that keeps the tab completion from working properly. And I won't set the clock. Now I can see now that I forgot a command back on switch 1. So I'm going to go to switch 1. What is the command I forgot to do on switch 1? Oh, I didn't do the console. So let's do a show running configuration. And we can see that I did the passwords for the BTY, but I did it for the line console. So I'll do configure terminal, line console 0, password Cisco, oops. Password Cisco, and login. And then I'll do a copy, run, start, and save that. Okay, now back to S2. Were we finished with S2? Did the banner message of the warning? Oh, we didn't do the saving of anything yet. So I'll copy running configuration to the startup configuration, and that switch is saved. I'm not going to do the clock thing. Okay, now step 3, let's configure our PC hosts. So I'm going to jump back to the chart on the front of the lab, and I will go in and configure our PC. So I'll click on the desktop IP configuration tab, and PCA is given as 192.168.20.3. Should fill up the 255s for us. We don't have to put a default gateway in this lab because there's no routers default gateways. We're not routing back and forth between any networks. That should take care of that one. Normally you can float over the device and it'll pop down a little screen and it says 192.168.20.3/24. That's proper. And I'll go over to the right and go to the configuration, rather desktop IP configuration. And his address is specified as being 192.168.20.4. So that mask. Finish with that. So just to check, I'll go to PCA, go to the command prompt, and type ipconfig. And we haven't done anything really on the switches yet to affect configuration. I ought to be able to ping 192.168.20.4, and I can't. So PCA can ping PCB. We're going to do things to the wires between the two switches and make them trunking ports and stuff like that. But right now, they're just everything's access port, everything's in VLAN number 1. We haven't assigned these ports 6 and 18 for the two PCs to. They're going to get VLAN 20. Switches are going to get VLAN 10. Okay, now we're at the middle of page 3, and I'm supposed to go to switch 1 and do some configuration on that. So I'm at the S1, and I need to be in the configuration mode to be able to make any VLANs. So VLAN 10, name management, VLAN 20, name clients. It's going to be our PCs. VLAN 10 is going to be our switches. VLAN 999, name parking lot, and VLAN 1000, which is we're going to use as our native VLAN, since it's good practice to move it away from the default of VLAN number 1. Now I'm going to go to switch 2 and repeat these steps. So log into switch 2, go to the global configuration mode, VLAN 10, name management, VLAN 20, that's the clients, our desktop PCAs and Bs. VLAN 999, name parking lot, and VLAN 1000, name native. And exit back out. Now we're going to do some management interfaces on both of our switches. So I'm going to go back and do it start from 1. We'll go to 1, expand the CLI, look good in the copy here. Okay, it looks good in the copy. Okay, back at the regular user exec mode, and we're supposed to go to interface VLAN 10 and give them the management address of that switch for S1. So I'll go to global configuration mode, interface VLAN 10, IP address 192.168.10. something, 10.11, add the /24. Do no shutdown, and exit. And then we're going to do the corresponding one on switch 2. So I'll pop into switch 2, go to the global configuration mode, interface VLAN 10, the address 192.168.10.12. Okay, and they're not going to be able to ping each other because the two wires between the two switches are still access VLAN 1, the default. We haven't made them a trunking port yet. Okay, I'm going to skip the C, assigning the unused ports and putting them in the shutdown mode just in the interest of time, but it's considered good practice that when you have ports you're not using, just so if somebody gets in the wiring closet and they find a port that's not plugged in, they can plug in and get access to your network. If you assign them to this parking lot VLAN, the garbage VLAN, they won't have any access to anything. Okay, now let's go back to our switches. We'll go back to switch 1, and we have to assign that port 6 to VLAN 10 or VLAN 20. Okay, so go in the configuration mode for switch 1 and go interface fast Ethernet 0/6 and switch port mode access, just to make sure it's not a trunking port, and switch port access VLAN. Now I'll repeat the process. Let's just verify this before we go. Show VLANs. If we can see that all ports are still assigned to the default VLAN number 1, the only port we've moved is port 6, and we put it in VLAN 20. Eventually, we're going to put ports 1 and 2. They're going to disappear from the list of access ports because they'll turn into a super duper ether channel trunking port between the two switches. Okay, let's go to switch 2. And switch 2, we're going to go to the global configuration mode and go to interface port 0/18. And say switch port mode access, and switch port access VLAN, wasn't it 20? There we go. Now he tells us to do the show VLAN command. So we did the show VLAN command on S1, and I didn't move all those other ports over in the interest of time, but port 20 was assigned to show VLAN. Port 20 was assigned to VLAN. Port 6 was assigned to VLAN 20 on the first switch, our PCA. PCB is connected to port 18 of this switch, and it's assigned to VLAN 20. They can't ping each other yet because we haven't set up a trunking between the two switches. Now, let's do some trunking between the switches. So he's going to have us start on switch 1. I'll go back to switch 1. Go to the global configuration mode. And let's say interface range fast Ethernet 0/1 through 2. Changes to config.if range, switch port mode trunk. You're going to get all sorts of crazy distressing error messages because nothing is matching right now between the two switches. So let's go to the global configuration mode on switch 2 and say interface range fast Ethernet 0/1 through 2 and say switch port mode trunk. Now we also need to set the native VLAN. So oops, let's get to the peer prompt here, and I'll go back to the configuration. Okay, I'm still at S2. I'll go back to the configuration mode. I got to get back into my interface range fast Ethernet 0/1 through 2 again. Interface range fast Ethernet 0/1 through 2. And then we're going to say switch port trunk native VLAN 1000. We're going to repeat that on switch S1. I'm allowed to drag this over here and have this here, and then have this here. Is the Macintosh going to allow me to do that? I guess not. Okay, so switch 1. I just did that on switch 1. So let's go on switch 2. Oh, I just did it on switch 2. Okay. Now we'll go to switch 1. And we're going to say switch port trunk native VLAN 1000. Otherwise, we're getting all these crazy messages that the native VLANs don't match anymore. Okay, now we're going to do some allowed trunking. We're still in the IF range? Oh, we went out of it. Okay, so configure terminal, interface range, fast Ethernet, 0/1 through 2, and switch port, trunk, allowed VLANs are going to be 10, 20, 1000. And then we'll repeat that on the second switch. Still in here, so switch port, trunk, allowed, VLANs, 10, 20, 1000. Let's check and see what's trunking here. We'll go back to switch 1. And we're going to type the command show interfaces trunk. We can see that ports 1 and 2 are trunking together with each other. We'll go to S2. We should get exactly the same similar sort of report. So I'll go to S2 and say show interfaces trunking. So ports 1 and 2 are trunking to each other. Now, however, let's look at the lights. Look at this green and orange wire pair. Both the link lights on switch 2 are green, but on switch 1, only port 1 is green and port 2 is orange. So what happened is as STP has partitioned off, he's blocking that port because otherwise it would create a loop. So we can verify this very easily by doing show VLAN. We can see, oops, let me do it again. Show VLAN, show span. And we can see that the root port 1 is activated and the port 2 has been put in the alternator block state. And if we look at the report, it says that the spanning tree, it doesn't say this bridge is a spanning tree, because on the root bridge, none of the ports will be blocked. They'll all be designated ports. So let's go look at our rule. He happened, just by accident of his MAC address, he happened to be designated the root bridge or the root switch. So show span, and it says, hey, it says this bridge is the root, and root bridges don't have root ports. Root bridges only have designated ports. All the other bridges, switches that are non-root bridges will have root ports and block ports or alternating ports is what Rapid Spanning Tree Protocol plus the default on our switches says. Okay, now we're going to go ahead and create the ether channel between the switches. So I'm supposed to be on S1 to do this. So I'm going to blank out S2, go back to S1. And we're going to go back into the global configuration mode and say interface range, fast Ethernet 0/1 through 2, and it changes prompt, changes the config range. And we're going to say channel group 1. That's an arbitrary number. It just has to be the same on both devices that are forming that one particular ether channel group, that link aggregation group. And he's going to use the mode. What are our choices here? We have active, auto, desirable, on, and passive. So a couple of those are port aggregation protocol, which is a Cisco proprietary one, but we're supposed to use the LACP, which is the 802.1 open standard one. So we're going to use mode active, which is LACP unconditionally. And we're going to do the same thing on switch 2. So I'll go to switch 2. Go to the global configuration mode, do an interface range, fast Ethernet 0/1 through 2, and then we'll say channel group 1 mode active. Now let's go back and look at the show interface trunk command and see what's happened. And we're going to see, before I do that, I want to do a show IP interface brief. And we can see that, can I make this bigger so we can see the whole thing? Is that visible to you guys? Okay, we got this new channel up here. Okay, we had our physical 24 channels of fast Ethernet, and we have our 2 physical gigabit channels. But we created a new logical bonding between these ports 1 and 2. It's called port channel 1. It's on the up and up. So that's the logical port channel here. And if I do show interfaces trunk, tells me that port channel 1, it looks like one wire. So what's happened? What's happened to our fast Ethernet 1, fast Ethernet 2 that used to be in there? Well, now they're aggregated together into this logical channel, port channel 1. It's got double the bandwidth. So our 2 original channels, which were 100 megabit each, but one was partitioned off. We were only getting 100 megabits of data because one of those ports was in the alternated block state. Now they're aggregated together. They're ether channeled together. We're getting double the bandwidth. We get 200 megabytes instead of the 100 megabytes we were getting. And we'll see the same thing if we go into back to switch 1. Okay, I'm going to be at the bottom now of page 7, and I'm going to type the command show ether channel summary, and we can see that everything looks pretty good here, because when we look at the bottom of this report, it tells us that we're getting port channel 1. We're using the LACP protocol. I'm looking kind of at the bottom line of my report here. And it says that ports 1 and 2 are aggregated together, and P, that legend tells us this P it's in the port channel. If there was some problem, it would say D, it's down. Something's wrong with it. So let's check on the second one. And do a show ether channel summary, and he's cool. Now, he doesn't try to do this in the lab, but I want to just show you this. Remember when we did show spanning tree protocol? And it told us that our on switch 1, told us that switch 1 was a bridge, and it was a designated. So let's go back to switch 1, which was the non-root bridge. Here's where we're going to see a difference. So show span, and now we can see that there's a root port back to the root bridge, and no longer is port 2 alternated. It's been bonded together. And the cost used to be, the cost for fast Ethernet is 19. Well, the cost for a 200 megabyte channel that's bonded together is a cost of 9. If we'd used the gigabit channels, it would have been even a less cost than that. Okay, so on this lab then, if you would do a screenshot of the show Ethernet channel summary for switch 1 and switch 2, and send those 2 graphics to me as a sign that you've completed the lab and done it properly. I'd be very, very happy to receive that from you. Okay, hang loose a second. I'm going to stop the recording. Oh, we're going to get this. Oh, woo, this is such a woo-woo thing here. Let me see if I can stop the recording.